Hello student, good morning. I am Dr. K.SINHA, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing electrochemistry. Actually I am reviewing electrochemistry. Means all fundamentals of this chapter I am going to review. Last class I have discussed in the end electronic conductors and electrolytic conductors. Difference between electronic conductors and electrolytic conductors. Now I am going to discuss about the electrolytes. What are the electrolytes? The compounds which in the aqueous solution or molten state conduct electricity are called electrolytes. The compounds which in the aqueous solution or molten state conduct electricity are called electrolytes, while those like sugar, urea, glucose, etc. which do not are called non-electrolytes. Means these urea, glucose, sugar, they will not conduct electricity. These are called non-electrolytes because in solution it will not conduct electricity. Then the compounds which in the aqueous solution or molten state conduct electricity are called electrolytes. Now Ohm's law. Ohm's law states that if the ends of a conductor a voltage E is applied and current I flows through it, then the resistance R of the conductor, that is E upon I, means R is equal to E divided by I. E means here volt, I means here ampere. It means R is equal to E upon I, means volt divided by ampere, means potential difference divided by current. Resistance is equal to potential difference divided by current, correct? And its unit is ohm, OHM, ohms. It is denoted by ohm. If R is the resistance, E is volt you can tell potential difference, and I is ampere, then R is equal to E upon I, and its unit is ohm. Now next term is conductance. What is the conductance? Conductance is the reciprocal of resistance, means C is equal to 1 upon R. If resistance is more, current will be less, and if R is less, current will be more. Its unit is per ohm or mho, MHOS, mho. Then conductance is the reciprocal of resistance, that is C is equal to 1 upon R, and its units are per ohm or mho. Now next term is, that is resistivity. What is resistivity? Then if L is the length of a conductor and small a is the area of cross section, then R will be directly proportional to length and inversely proportional to cross sectional area. It means we can tell R is directly R is proportionality sign you can write, then L upon A. L is upside, means directly proportional to length, and A is down, means cross-sectional area, it means inversely proportional. Hence R, you can write R is proportional to L upon A. And if you want to equate in the term of equality, then we have to multiply it by some constant. Then R is equal to rho L upon A. Then rho is constant, and it is called actually a specific resistance. And this specific resistance is also called resistivity. Then R is equal to rho L upon A, where rho is called a specific resistance or resistivity. Now, what is the specific conductivity? A specific conductivity, lambda, you can tell sign is the lambda. Then a specific conductivity or simply conductivity is also called conductivity. Nowadays it's called conductivity. Then a specific conductivity or conductivity, both are same. Then a specific conductivity is the reciprocal of a specific resistance. A specific resistance. Then now I told you rho is the specific resistance. Rho is the specific resistance. Then here a specific conductivity is the reciprocal of a specific resistance, that is K. A specific conductivity or simply conductivity is denoted by K. Then K is equal to 1 upon rho. 1 upon rho. Hence, now these two equation I told you, R is equal to rho into LA. R is equal to rho into L upon A. And now K is equal to 1 upon rho. Correct? These two equation is there. Here in the place of rho, it means you put the value of rho from the equation R is equal to rho into L upon A. From here, rho value you put here, K is equal to 1 upon rho. Then putting the value of rho, you will get R is equal to, actually this value already told you, R is equal to rho into L upon A. L upon A. Then this, by using this value, rho value you have to put here in K is equal to 1 upon rho. Then what you will get? K is equal to C into L upon A. Correct? C is conductivity. C I told you conductance. Conductance is the conductance that is denoted by C. Then conductance is the reciprocal of resistance, means 1 upon R. Then using this equation, C is equal to 1 upon R, and other equation R is equal to rho into LA, and third equation K is equal to 1 upon rho. Then here this K is equal to 1 upon rho value you have to put. Correct? Rho value. Then you will get K is equal to C into L upon A. Correct? Then this is actually expression for a specific conductivity. A specific conductivity, K is equal to C into L upon A. Now actually you have to use this three equation I told you. With the help of that, just you can get the value of rho, because R is equal to rho into L upon A, and R is equal to, also I told you, C is equal to 1 upon R. C is equal to 1 upon R. Then from that R value you can get R is equal to 1 upon C. C is equal to 1 upon R. Then R is equal to what? 1 upon C. Then here in this equation R is equal to rho into LA. Then in the place of R you write 1 upon C. 1 upon C. Then 1 upon C is equal to rho into L upon A, then rho value you can calculate very easily. And after that you put rho value in K, in the K is equal to L upon K is equal to 1 upon rho, there rho value you put, then you will get K is equal to C into L upon A. If, now further you see, if L is equal to 1 centimeter and A is equal to 1 centimeter square, then you will get K and C both are equal, K is equal to C. If L upon A is there, C into L upon A. If L is equal to 1 centimeter and A is equal to 1 centimeter square, both are 1, then in that situation K is equal to C. Hence conductivity is the conductance of 1 cubic centimeter of the conductor, and its unit of K is equal to ohm per centimeter. Okay, ohm inverse, centimeter inverse. This is the unit of specific conductivity. Question is asked, unit of specific conductivity. Expression you keep in mind, then obviously you can write the unit also. Expression is very, very important. K is equal to C into L upon A, you remember. And here what is actually L upon A? Then L upon A is called Shell constant. Its value is fixed. It is called Shell constant. Hence you can tell also that K is equal to conductance into Shell constant. K means a specific conductance is equal to conductance into Shell constant. L upon A is called Shell constants. Now next term is equivalent conductivity. Just in the same way you can define the equivalent conductivity. What is equivalent conductivity? Equivalent conductivity of a solution at all dilution. At all dilution. Dilution means here capital V, you can tell, volume. Equivalent conductivity of a solution at a dilution V is the conductance of the all ions produced when 1 gram equivalent of the electrolyte is dissolved in VCC of the solution. Means ion produced by 1 gram equivalent mass of the electrolyte. 1 gram equivalent of the electrolyte, when it is dissolved in VCC, it produces ions. Then conductance of all the ions produced when 1 gram equivalent of the electrolyte is dissolved in VCC of the solution, cubic centimeter, Cc means. And second, distance between the electrode should be 1 centimeter. Distance between the electrode should be 1 centimeter. And third point, area of the electrodes is so large. Area of the electrode is so large that the whole of the solution is contained between them. Means here distance between the two electrodes is 1 centimeter and area of electrodes is large, so that the whole solution is contained between them. Okay, means solution will be between the electrodes which is maintaining 1 centimeter. Then equivalent conductivity of a solution at dilution V is the conductance of the all ions produced when 1 gram equivalent of the electrolyte is dissolved in VCC of the solution, and distance between the electrodes should be 1 centimeter and area of the electrode should be so large that the whole solution is contained between them. Now next point, that is the relation between equivalent conductivity and specific conductivity, how both are related. That is very, very important. Means equivalent conductivity, relation between equivalent conductivity and specific conductivity. Specific conductivity is denoted as K or sometimes kappa also. Then now equivalent conductivity, it's actually represented as delta EQ. EQ means equivalent, small e, small q. Then here this equivalent conductivity is equal to K into V. Kappa into V also you can tell. Then K into V means K actually that is per cc. K is the conductance for 1 cc. Then for VCC, in VCC what is the conductance? That is the equivalent conductance. That's why you just simply multiply equivalent conductance is equal to a specific conductance into volume. Correct? Then volume, this volume contains 1 gram, you can say gram equivalent. This volume contains 1 gram equivalent, you remember. Hence you can write that equivalent conductance is equal to kappa into 1000 divided by normality. Because now normality, what is the normality? Then number of equivalent present per liter. Number of equivalent present per liter, that is the normality. Suppose in 1 liter, if 1 gram equivalent is present, then 1 n, solution is 1 n. If 2 gram equivalent weight is present, then 2 n. If 3 gram equivalent is present, then 3 n. Example, NOH, its equivalent mass is 40. NaOH 23 plus 16 plus 1, 40. Means if 40 gram means 1 equivalent. If 40 gram is present in 1 liter, then 1 n solution. If 80 gram, then 2 n. If 120 gram, 3 n. Same way, 40 gram means 1 equivalent. If suppose n by 10 is present, means 4 gram is present, then solution will be n by 10. Correct? Like that way, 0.4 gram is present, again it will be, you can say 1 upon 100, n upon 100, like that way. Then equivalent conductance is, I told you, that is a specific conductance into 1000 divided by normality. Okay, because in 1 gram equivalent, V volume K into V I told you, but in this V, you can say 1 gram equivalent weight minimum, that is, but you don't know how many gram equivalent weight is present there. In general, suppose it is C gram equivalent weight is present, C gram equivalent. Correct? Then per gram, you have to calculate. C gram equivalent is present in 1 liter. 1 liter means 1000 cc. Then 1 gram equivalent will be present in how much cc? Volume 1000 divided by C. C gram equivalent is present in 1000 cc. Correct? Then for 1 gram equivalent is present in how much? 1000 divided by C. This is actually volume. That's why K into V. Then in the place of V, you can write 1000 divided by C gram equivalent. And this C gram equivalent actually you can tell normality. Hence, you can say equivalent conductivity is equal to K into 1000 divided by normality. This is very, very important relation, where V is the volume of the solution in cc, cubic centimeter, containing 1 gram equivalent of the electrolyte, and CQ represent the concentration of the solution in gram equivalents per liter, also called normality of the solution. What is its unit? Units of equivalent conductivity is very, very important. Question is asked. Then if a formula you are knowing, then only from the formula we are knowing the these things, unit. Then after putting this formula, normality, you can say what is the unit of normality, all the things you will put, then you will find the these things, unit of equivalent conductivity. Okay, then here unit of equivalent conductivity will be ohm per ohm centimeter square per equivalent. Again I am telling you per ohm because K you know, K already I told you its unit is K unit is ohm inverse per centimeter. Unit of K is per ohm per centimeter, ohm inverse per centimeter. Then here in the formula I will put the ohm inverse per centimeter for the K, 1000 divided by normality. Correct? Normality means per equivalent. Then after putting all the things per equivalent, then you will find, and volume unit is cc, cubic centimeter. Correct? Cubic centimeter, centimeter power cube. And here you have seen in kappa, in K, it is ohm inverse per centimeter. Then 1 centimeter will be cancelled, then centimeter square will be remaining. Then finally you will get ohm inverse, and this volume unit was centimeter cube, or down per centimeter was there for the K, ohm inverse per centimeter, it was down. Then 1 centimeter and 1 centimeter will be cancelled, then centimeter square will be remaining, and per equivalent, because normality is down, normality is written down, hence per equivalent. Then its unit is equivalent unit of equivalent conductivity is equal to ohm inverse centimeter square per equivalent. Now molar conductivity, it is again same way like equivalent conductivity. Here in the place of equivalent you have to use the term mole. Okay, then it is also a small m, it is represented by delta small m. Then molar conductivity of a solution at a dilution V, V means volume. Then molar conductivity of a solution at a dilution V is the conductance of all the ions produced when 1 mole of the electrolyte is dissolved. It is important. 1 mole of the electrolyte is dissolved in BCC of the solution. Then 1 mole means it will produce many ions. Then conductance due to these ions. First point, again same way. Second point, distance between the electrodes should be 1 centimeter. And third, again, area of the electrode should be large, so large that the whole of the solution is contained between them. This is the actually molar conductivity. In a simple way you can define molar conductivity of a solution at dilution V is the conductance of all the ions produced when 1 mole of the electrolyte is dissolved in BCC of the solution, and electrode distance between electrode is 1 centimeter, and area of the electrode is so large that whole of the solution is contained between them. Now same way, what is the relation between the molar conductivity and specific conductivity? What I discussed, same way here, again it is there, relation between molar conductivity and specific conductivity. Then all expression will be the same, means delta m, only symbol is changing. Delta m is equal to K into V, again K into V is equal to again 1000 divided by Cm. There that time we written C equivalent, concentration. Now we are writing for C means concentration, Cm, a small m, molar conductance, that is called molar conductance. Then V, K into V, molar conductivity is equal to K into V, same way what I discussed. Then again K into 1000 by Cm. Again you put in the place of Cm, that is a Concentration is expressed in normality, correct, in molarity also, many ways. Then in the place of CM now you can write molarity. Earlier case you have written normality, now here molarity, same way. Then delta M is equal to K into 1000 divided by molarity, where V is the volume of the solution containing 1 cubic centimeter. Volume here, V is the volume of solution in cc containing 1 mole of the electrolyte, and Cm is called molar concentration, means mole per liter. Molar concentration means number of mole or moles per liter, correct. Again its unit is the same way. Per ohm means ohm inverse centimeter square per mole, correct. Ohm inverse centimeter square mole inverse, or you can tell per ohm centimeter square per mole. Anyway, better remember ohm inverse centimeter square mole inverse. Same way, just like this equivalent unit of equivalent conductivity. Same way, no difference at all. Okay, only in the place of equivalent here you will write mole per mole. Now further again you can see K is equal to C into L upon A. Then for a particular conductivity, this relation already discussed, K is equal to C into L upon A. Then here for a particular conductivity cell, actually L upon A value already I discussed, that is called cell constant. Okay, in conductivity cell means you know that cell always means electrodes will be there, one anode, one cathode, and electrolytic solution will be there, and both electrodes will be joined through ammeter or voltmeter. This arrangement actually is called cell. Then because this cell you are using for measuring conductance, that's why it is called conductivity cell. Then here for a particular conductivity cell, L upon A is constant, because length will be, I discussed, L value will be fixed, cross sectional area will be also fixed for a particular electrode. In a cell, that electrode once what is fit, that will be fit, you can't make change for whole life. For that cell it is fixed, hence a cross sectional area is fixed and L is fixed, hence L upon A value is fixed, and this L upon A is called cell constant, means cell constant of a conductivity cell is fixed, constant. Okay, L upon A is constant, and this is called cell constant. Hence a specific conductivity is equal to conductance into cell constant. Now I am going to discuss effect of dilution. Suppose solution is there, solution you have taken, suppose that was the concentrated solution. Now if you will add water in that, means a dilution, you are diluting the solution, then what will happen? How will it affect conductance? Conductance will increase, decrease, what will happen? Conductance means always you think in mind that movement of ions in solution. Okay, in that way you have to think. Then effect of dilution, I am discussing now what will happen. Conductance increases, you remember, conductance increases, specific conductivity decreases. Two terms are there. If you will increase volume, if you will dilute the solution, then conductance increases, but specific conductance decreases. Why actually a specific conductance decreases? Then now you can see, suppose you have taken in the beginning 100 cc solution was there. In that one, suppose one in 100 cc, suppose 1000 ions was there, correct? In 100 cc, 1000 cc ion was there. Then in 1 cc, how much will be there? You can calculate very easily, In 1 cc, or simple general we think that in 1 cc, when solution was concentrated, 10 ions was there. Now you have diluted. Then now in 1 cc, their number will be less, because volume is more, they will move fast. Then per cc now, ions will be less. Ions will be less per cc. Then a specific conductivity is related to per cc. That's why it decreases. This specific conductance decreases, but overall conductance increases. Why? Because when solution was concentrated, then ions wanted to move, but they were restricted only in 500 cc. But now you have increased the volume, diluted the whole solution, then now they are free to move further. That's why conductance will increase, because conductance is related to the movement of ions. Then conductance increases, but a specific conductance decreases. And what about the equivalent and molar conductivity? Then both increases. Equivalent conductance and molar conductance both are related to conductance only. Then when conductance is increasing, it means equivalent conductance or molar conductance will also increase with dilution. Only a specific conductivity will decrease. Now, variation of molar conductivity with concentration for a strong electrolyte, I am going to discuss. This is the last of today's class. Last point. Variation of molar conductivity with concentration for a strong electrolyte. Actually, it is given by Debye-Huckel-Onsager equation. This variation is given by Debye-Huckel-Onsager equation. Actually, all three are these are the name of the three scientists. Debye, first scientist, second Huckel, third Onsager. Then variation is one expression was given by these three scientists, and that equation is known as Debye-Huckel-Onsager equation. This is for to measure the variation of molar conductivity. Okay. Then what is that equation? Then that is the delta M, molar conductivity, and only on delta M, if you write upside a small zero subscript, then that will tell zero subscript means infinite dilution or zero concentration. Both are same, because if solution will be considered diluted, the concentration will decrease. Correct? Then you can think, you can assume that concentration is decreasing, then concentration may become zero. Then both are the same, zero concentration or concentration at infinite dilution, both are same. Then here one equation was given by Debye-Huckel-Onsager, that is known as Debye-Huckel-Onsager equation. According to this equation, delta M is equal to delta M at infinite dilution, subscript 0 you can write delta M and upside a small 0 minus B under root C. Total term I am telling you, first delta M, that is equal to delta M at infinite dilution minus B into root C, where B is a constant. Depending upon the nature of the solvent and temperature. Okay, B is a constant, and under root C is the concentration, and delta M is the molar conductivity, and that actually you can understand like that at conductivity will be highest. Conductivity will be highest at zero concentration, free, full free, that value is maximum at infinite dilution, conductivity will be maximum because electrons are free to move. But there will be also, you have to decrease some value from that. That is that why you are decreasing some values, because some this value there, B I told you that is a constant. Its value depends upon the solvent, what type of solvent you have taken, and at what temperature you are doing the experiment. Correct? Then this constant, this due to this nature, suppose it is a viscous solution, because different type of solutions are there, then every solution, every solvent you can tell, every solvent have different coefficient value, means resistance power. It will not allow to move very fast. It will work against movement. Then every solution, every solvent has some resistance. That is what we are telling, viscosity. Then due to that, it will create a little problem in a fast movement, and temperature also. Hence this B value, constant value, little its conductance will decrease. Then how much that value is there, you have to deduct from the conductance at infinite dilution. Little you can say conductance, which is you can say due to the nature of solvent and temperature, now little conductance is decreasing, some conductance is decreasing. That's why you should minus it. Then that what you will get, that is the actually molar conductivity. That's why this term is introduced, B into under root C. Correct? Because B here is a constant depending upon the nature of the solvent and temperature. On both B value depends. That why from the maximum you are decreasing little value. B under root C, where C is concentration. And this delta M at infinite dilution is the molar conductivity at infinite dilution. From the graph also you can see, actually what I told you, in case of a strong electrolyte like KCl, NaCl, these are the strong electrolyte, HCl, they will move fast. But all weak acid or weak acid base, that it is not applying on them. What I am discussing now today, that is only for, you can say, a strong electrolyte. Weak means already their conductance will be less only. Weak electrolyte, NOH, this not NOH. You can say, take example of ammonium hydroxide. Ammonium hydroxide is a weak electrolyte, ammonium hydroxide, and sodium acetate or acetic or all organic acid are weak electrolyte. But now I am talking about a strong electrolyte like a Cl, NaCl, KCl, HNO3, like that. All are strong. Then in a graph you can see, if you will draw the graph plot, delta M versus root C. C is the concentration. Then nature of the graph you can see in the graph, that in the case of a strong electrolyte, it is just like not fully straight, little curve is there, little with increase of concentration under root C I am talking about, that little variation will be there. Okay, with under root C, that little change will be there. It is not little curve we will find. Okay, when concentration will increase, means under root C will increase. And weak electrolyte, now their molarity will be very less. Example I told you, acetic acid, any weak electrolyte, but this case acetic acid, because graph is taken for a strong electrolyte KCl. In the name of a strong electrolyte, KCl was taken, and for weak acetic acid. Then see how you can say molar conductivity, molar conductivity decreases for weak electrolyte. It is coming down. See C value at when root C value was very less, then molar conductivity was also very less, correct. But as the concentration increased, then molar conductivity also little increased in case of weak acid, acetic acid, and after that it will become little constant. It will become with increase of concentration, it will become little constant. In case of weak electrolyte, it is coming down, but in a strong electrolyte, see its conductivity is high, molar conductivity is at the top, high, more. Upside means more, down means less. Then now you can see in comparison to acetic acid, weak and strong, that strong electrolytes conductivity is more. Okay. Then this I have discussed about the variation of molar conductivity with concentration for a strong electrolyte. Now again I will continue in the next class. Many terms are there and all are very, very important. If you understand all the, you can say, terms, then only you can solve the, you can say, questions, maybe theoretical or numericals. Okay. Now I am stopping only here. Thank you.